Hello and thank you for tuning into this video on the Rip Current Forecasting and Monitoring Program here at the National Weather Service in Gray, Maine. I'm meteorologist Michael Clare, and today we're going to be talking about the National Weather Service and our mission, and we'll be diving into some science on rip currents. We'll discuss our daily recreation forecast products, and also how we issue them and how we monitor them. And then we'll be discussing what lifeguards see on a daily basis and how that can play a role into our forecast, and how working together could help to improve our products through a local partnership. So kicking off with our mission here at the National Weather Service, our mission is to provide weather, water, and climate data and forecasts and warnings for the protection of life and property and to enhance the national economy. And our vision here at the Weather Service is a weather-ready nation, which means a society that's prepared for and responds to weather-dependent events. So in the spirit of that, today we're going to be diving into rip currents. So just talking about a little bit of common terminology right now. There's a few different terms that get thrown around when discussing rip currents, but there actually is a difference between them. One of the phrases that's commonly used is undertow, and what undertow actually is, it's just the movement of water along the bottom of the ocean associated with passing waves. You'll sometimes hear them called riptides, but a riptide is actually just the motion of the water due to the changing tides. So what we're going to be focused on is a rip current, which is a strong, narrow, and concentrated seaward flow of water that extends from close to the shoreline through the surf zone to variable distances. And basically all that means is it's a channel of water that's moving away from the beach and out into deeper water. So that's what our focus is today. And just a little bit of the basic science behind rip currents. A rip current forms from waves coming in across a sandbar, and then the water that comes in with those waves having to head back out. So the water moves back out in a break or a channel in the sandbar, and then once that rip current is established, it kind of maintains itself by moving through that break in the sandbar. So water feeds in and then it flows out where the rip current is occurring. And looking at it a little bit more from above in a real world example, it's really a whole system, the rip current. So where the rip current is where the water's flowing back outward, but off to the sides of that rip current there's water generally flowing inward towards the beach, which is the supply for the water coming out. So that water is moving in along with the waves coming ashore. So this is why when we're discussing rip currents they say to swim parallel to the shoreline and then back in, because it's generally a circulation that's flowing as part of that rip current system. And taking a look at a video here, we can see that from above. Once we get this going, you can see that they put dye in the water here to show where the rip current is. And as the video progresses, you'll see that the dye moves out in a narrow channel in an area where there's no breaking waves. You'll see the waves breaking on either side of it. But that ink dye flows outward and away from the beach and kind of in pulses still. And as we look a little closer at what we saw in that video, you'll notice that there's an area where the ink dye is moving away from the beach, but then on either side of it is where the waves are breaking, and generally the water looks pretty rough. So this can actually be very deceptive to swimmers. It looks like this would be the calmer area in here to swim, but in reality that's where the rip current is, and that's where the threat is to being pulled out into the deeper water. So shifting gears a little bit, we're going to dive into our recreation forecasts, and here at the Weather Service we issue forecasts for hiking areas and skiing areas at mountains, lake forecasts for boaters out on the lake, some coastal sites, but what we're really focused on is these area beaches, and part of that is the rip current risk. So this is just an overview of what our recreation forecasts actually look like. This is for one of the local beaches here at Old Orchard Beach. And you'll notice you get a detailed forecast for the next couple of days with all different aspects of the weather, water temperature, things like that. But then you'll also notice uh, right here we have the rip current risk, and over here at the end of the product is an explanation of what that risk translates to in real life. So it's pretty intuitive. The higher the risk, the greater the risk of rip currents. But one thing to note here is that even on a low risk day, rip currents are always possible near jetties, piers, and permanent structures. So some of the factors that can lead to rip currents here are piles of rocks, any jetties, piers. So those are all present at many of our beaches across the area. So to actually issue that forecast, this is where that product comes from. From our forecast grids, that gets translated into the recreation product. So here on the left we have an example of a low risk day, and it's all green. Green means good, and the factors that go into that forecast are largely based on waves and periods, but also the direction of where those waves are coming from, and also wind direction. And then this is just an example. This wasn't a real day, but this was just meant to show what the forecast looks like when we have either a moderate or high risk. As the waves and swell periods grow, the chance of rip currents increases, so we start to get some of these yellows and reds in our forecast database, and that would translate to a moderate or high rip current risk in our recreation product. So once we issue those products, we do monitor what we're actually seeing down on the beaches. We have some very helpful webcams from around the area. This one here down in Old Orchard Beach, you get this wide angle view, and you can see a rip current here showing up on the webcam. But from where we're at, we got a pretty big view, but not a ton of detail. And then this is another webcam down in the Ocean Park area of Old Orchard Beach. So it's a bit grainier, but you can still make out that there's a rip current here. But what the lifeguards see daily on the beach is they're sitting right there overlooking the water, and especially up in the tower have a very good vantage point of where rip currents are actually occurring and how severe they may be. So we want to try to bridge the gap between what we can see from our office on the webcams to what the lifeguards can see down on the beach, so that even if they're not there or it's in the off season when we're trying to calibrate our forecast, we can make out what we're seeing on the webcam translates to what people are seeing down on the beach. So to bring those two together, we've created this rip current reporting form, and this is actually part of a system across many beaches along the East Coast, the Gulf Coast, and even on the Great Lakes. So we tailored this form to our specific area. So when you start with the form, this is what you see, and then you choose your beach. In this case, we'll be picking Old Orchard Beach. And then as you go forward on the form, you pick the date, and then also what time the rip current started, if applicable. If they've been going on all day, then it's not applicable and it can be left blank. And we also have what time the rip currents were observed to have ended. This can be left blank if they haven't ended or they're still ongoing. And if they haven't ended, it would be because there are no rip currents. So when we're talking about rip current strength, we have a range from none, so the days that there's nothing, up all the way up to powerful, which are kind of the events where you get a large hurricane swell in the summertime with lots of swimmers. These are the highest end days. So that's kind of what the rip current strength translates to. And then we've tailored it so that you can select specific areas on the beach. Some areas are much more well known for having more rip currents, so we tried to break it down to pick out which areas are seeing them. And then we also have a section here for the number of rescues, because just because you have high rip currents doesn't necessarily mean you'll have many swimmers, so you need both in order to wind up with rescues. So we're trying to incorporate some of the non-meteorological factors into the forecast. So we have our forecast, but we also want to know what that translates to when people are actually out. There's a section here for the wave height, and then a section here on the longshore current, which is the water moving along the shoreline that actually feeds into the rip currents. And then some of those other factors here that influence swimmers, we have a section for the water temperature and also an area for water quality. So discussing seaweed, whether it's kind of thick and dirty or if the water is clean and nice. We believe that will have an impact on the number of swimmers, so we're trying to gather that information so we can try to quantify kind of which rip risk leads to the most rescues and swimmers all combined. And then once you send that information to us, this is actually what it looks like. And it's been a pretty tame summer so far, so we haven't really had many events since the program started. But just to have a little data in there, this is what it looks like. And this is what we receive when you fill out the form. A little more information here talking about the seaweed, and on that form there's a section for any additional comments that might be good to note. You can add on at the end there. So in conclusion, we're gathering verification to try to help improve our forecast, and we're looking for information on factors that even go beyond the rip current. So we're certainly interested in the rip currents, but then we're also monitoring the weather conditions, and we're interested in the water temperature, the times of high and low tides, and how many people require rescuing, because where the high and low tide falls during the daytime can have a big impact on how many people actually wind up being rescued, because generally the rip currents will be stronger at the lower tides. So this project aims to try to quantify how much each of those aspects are a factor. And then once we can help improve our forecast and have a better understanding of what it translates to on the beach, it will improve our recreation forecast, which will then be more valuable to the public in general. So thank you for tuning in and learning about our Rip Current program here at the National Weather Service in Gray, Maine. You can reach out to us at any time with questions. Our office email is gyx.skywarn@noaa.gov, and you can also call the office at 207-688-3216. Thanks for tuning in, and I'm meteorologist Michael Clare here at the National Weather Service in Gray, Maine.